All right, and welcome back once again to live session 4, What You Missed Recap. This is part 3, so if you're looking for factoring, that was part 1. If you're looking for degree and everything that tells us all the way through in behavior, that's part 2. Part 3, we're going to talk about intercepts, multiplicity, and then putting it all together. So let's start first with x-intercept, something we should all feel pretty comfortable with now. So we know our x-intercept is where the graph touches or crosses the x-axis. We find it because it's the values of x that make the function equal 0. And as a reminder, we did that earlier this week. Y-intercepts, on the other hand, is where the graph crosses or touches the y-axis. We find it because it's the value of y when x equals 0. So we can always find it by making x equals 0. Then we have this new term here called multiplicity. I'm doing a similar color because it is related to an x-intercept. They go together. The multiplicity is going to tell us more about our x-intercept than you've ever known before. So the multiplicity algebraically, or in the equation, is the exponent on a factor. So for example, if I have x plus, let's try that again to match what I was trying to say, x plus 2 cubed, then my multiplicity would be 3 because that's the exponent on the outside of my factor. Graphically, it determines the behavior of the graph at the x-intercepts. So that's why I said it's related. It's going to tell us how the graph is dealing at the x-intercept. Is it crossing it? Is it touching it? Is it crossing it normal? Does it have a little attitude? That's what it's telling us here. So the first option is that it goes straight through. I call this normal. So the way that you guys have been graphing for years, kind of like a line or parabola, when it just goes straight through the x-axis, you're not thinking about it. That is what we mean here. And this happens when your multiplicity is equal to 1. So when your factor just shows up once. There's something called a squiggle. That's our lovely technical word here, squiggle. It looks something like this. So this would be the behavior at the x-axis. It kind of flattens out a little bit before it gets super vertical again. And so this happens when your m is odd, but greater than 1. So we know 1 is an odd number, technically. But so this is odd numbers that are greater than 1 because 1 was in its own category. The last one then is when it bounces or touches. So it comes up, it hits it, and it turns around. Or it comes from the other direction, hits it, and turns around again. So that's what we mean here. And this is when your m is even. Another way to think about this one is the x-intercept is a turning point. So that's really what we mean by bouncing and touching, is that your x-intercept is a turning point. So we're going to look and see how can we use this information to help us out. So the first thing we want to do is we want to find those zeros. I know I'm going to have a 0 at -2. I'm going to have a 0 at 1, and I'm going to have a 0 at 3. Then we want to find those multiplicities. Once again, those are based on the exponents on those factors. So -2 came from this factor, so my multiplicity is 3. 1 came from this factor, so its multiplicity is 5. And last but not least, 3 came from this factor, so it has a multiplicity of 2. Using those rules we just talked about, these are going to squiggle. This one's going to bounce. So let's sketch that out. Okay, So I'm going to go ahead and just put the location, general location. I have a -2, 1, 3. I am going to say, because there's not a negative sign in the front, I know that this is a positive graph. And I know for positives, the right side goes up. So I'm going to say that up here, this is going up at some point. So that's going to be the information that I use to start. So I know from this 3, I need to go up to this arrow. But then I come over here and say, what's it supposed to be doing? Oh, it's supposed to bounce. So it means it's going to hit it. It's going to turn around and go the other direction. So notice it did not cross. Now I know I need to get back to the 1. Here, it's going to squiggle. So I'm going to turn around. I'm going to try and get to the 1. And it's going to go skrr, and then it's going to keep going down. So this is what I mean, I squiggle. You can see I zoom in real good there. It just kind of did that weird little thing right here where it got close and it went skrr, and then it kept going. And then we can do the last thing here. This one is also a squiggle. So as we turn around and come up to it, I'm going to start on the other side because I think it's easier to draw this way. It's going to do that weird kind of squiggle through it. And that is sketching a graph using multiplicities. So we are ever so close to being done. We have a few examples of putting it all together. So we did one of these in class. We're going to do that one again, and then we're going to do some other ones. So number 1 is the one that we did in class. We can go in and talk about this. So I'm actually going to start with it's in factored form, which this one is. It's actually easier to start with your zeros. So I know I have a 0, a -1, 2, and 4. The multiplicity here is 1, 2, and 1. So the reason why I did that is because we need to know the information about our leading term. Is it positive or negative? Is it even or odd? So I did tell you, you're going to find out if it's positive or negative if it's in factored form by is there a negative sign there? There isn't, so I know it's positive. I now need to determine if it's even or odd. That comes from summing up your multiplicities. So this is something we didn't really talk about, but you should know, is that your degree is the sum of your multiplicities. So 1 plus 2 plus 1 is 4, and that's an even number. So I know that my end behavior, if I draw a sketch, is going to look like this. Both ends are going to go up. In that formal notation, that means my left-hand side is going up, my right-hand side is going up. All right, the last thing here then is our y-intercept. Remember we said you find your y-intercept when x equals 0. So 0 plus 1 times 0 minus 2 squared times 0 minus 4. That's 1 times -2 squared times -4. So that's 1 times 4 times -4, which equals -16. My y-intercept is going to be 0, -16. Now I can actually use all of that to sketch out my graph. The first thing I'm going to do is I'm going to go ahead and put in that -16 way down here. I know it's super low. Because we're giving a sketch, your scale doesn't have to be perfect. And that's just, you can see there's no numbers here. We're just sketching. The next thing is I'm going to put in my 0. So I have a 0 at -1. 1 at 2, and I'm actually going to extend this out a little bit. Oops. And put 1 over here at 4. So try and get my numbers kind of spread out. Because of my end behavior, I know this side must be going up. I know this side must also be going up. So that's going to give me a guiding place to start. I like to start on the left because it's easier. The multiplicity for 1 is 1, so it's going to go straight through. I'm going to go down to the y-intercept, and then I know at some point I have to turn around. As I decide what to do here, oops, I'm going to see that at the 0, 2, the multiplicity is 2, so it's going to bounce. So I'm going to come up to it, I'm going to hit it, I'm going to turn back around. Last but not least, I know I'm going to turn around to get here. When I get to it, it's just going to go straight through. And that is sketching a polynomial using the information we've talked about. Some of the things that might be different for graphs are how far down you go. We don't know the exact point of our maximum and our minimum unless we are doing very specific calculations on the calculator, which we will talk about next week. But for now, we can just go ahead and give a brief dip, a brief skip. You can figure it out. Some of you guys' graphs may have looked more like this. Yeah, that was bad. So both of those would have been okay because they hit all of the points and they hit the behaviors that we knew. So know that sometimes your sketches might look different when we're not using actual technology. Okay, let's use this color. So this one we're going to come in. This one was given to me in standard form. So in standard form, I can find some other things a little bit quickly. I can go ahead and find that leading term really quick. My leading coefficient is positive and my degree is 3, which is odd. So I have a positive odd. That means that sketch-wise it looks like this, which tells me that my left-hand side is going down. My right-hand side is going up. I can also quickly find my y-intercept. But it's going to be a lot harder to find my zeros. That's because I'm in standard form. So what we must do then is factor. So that's why we reviewed factoring. In order to factor this, the first thing I'm going to do is at GCF, take that x out to the front. Now, my a times c is -4. My b is -3. So I want two numbers that multiply to give me -4, but add to give me -3. I think that's going to be 4 and -1. Just a double, oops, see, I even did that wrong. That's why we always double check. It's -4 and 1. So -4 times 1 is -4. -4 plus 1 is -3. So I have x minus 4, x plus 1. When I do that, I can now find my zeros. Each of them did not have an exponent. There was nothing here. So that means that it's really all a multiplicity of 1, which is pretty cool. I do want to point out something different. So 0, 0 lands in both the y-axis and the x-axis. So if you ever have it as an x-intercept, note that you also have as a y-intercept and the other way around. So it needs to be listed in both places. I can go back to graphing this guy now. I'm going to erase some of this factoring stuff to get out of the way. Just like we did earlier, we're going to put in our zeros and our intercepts first. So I have one at 0, 0. I had one at -4, and nope, I don't. I have one at -1 and I have one at +4. There we go. Sorry about that. Because of my end behavior, I know this side's coming from down here. I know this side is ending up here. So that end behavior. They all have a multiplicity of 1. So I know that for each of them, I'm just going to go through the x-axis without doing any weird behavior. And notice I didn't use those exact arrows that I had drawn. They were there just to give me a guide. Last thing, once again, is remember the heights of your maximums and your minimums might look different from person to person. So these two were using an equation, and you can see the benefits of factored form versus standard form. Some of them are really easy to find the leading term in your y-intercept, standard form, versus factored form is easier for finding your zeros and your multiplicity. So we will use both of them while we're graphing. And then this one is the last, and it actually goes the opposite direction. It has us take a graph and turn it into an equation. So can we go in the backwards order? We're going to find a lot of the same stuff by using our information here. So first off, my end behavior, they're going in opposite directions. So my left is going down and my right is going up. So that tells me that it's odd because they're going in different directions. And it's positive because the right-hand side is going up. I can also come in here, I can graphically see my zeros. I have a 0 at 0, 0. And I have one at 4. Immediately, I have a 0 at 0, 0. We know that, we have our y-intercept there. We just talked about that if you have it as one, you have it as the other. The multiplicities. If I come over here, I can see that at 0, 0, it's bouncing. So my multiplicity has to be 2, versus here it's normal or straight through. So my multiplicity has to be 1. Now we want to put all these pieces together. We know that our zeros create our factors. So I have x equals 0 and I have x equals 4. I want to solve those for 0, so move them around to get 0 on the side by itself to get the factor. This one's already done for me. So x is just the factor. For this one, I'm going to move 4 to the other side, so x minus 4 is my factor. Now, I need to go in and I need to deal with the multiplicities. Because there is a multiplicity of 2 on 0, 0, I know that this is squared. The last thing I want to check is to make sure that my leading coefficient doesn't need to be positive or negative. And I go back up here and I say, hey, it was positive. I don't need to do anything here. If this had been negative, then I would have put a negative here. So this is our function. If it's told this is in factored form, if I asked for it in standard form, you would just multiply it out. So that would give me x cubed minus 4x squared. Both of these are your final answer.